I feed them down in the hallways.
Okay, guys, what it says right here. In the year 2000, the librarian's salary was $25,000. In 2002, it was $27,500. If it's a linear growth model, what will the salary be in 2006? All right, so what we're going to have to do here is find the linear equation. So tell me what I need to do. How am I going to get the equation of this linear model or the line? Well, what do I need to calculate first? Slope. All right, so we need to do slope. Change in y over change of x. So this is x, this is y. This is x, this is y. Do you think that makes sense to let what is independent? Is the year independent or the money she makes? The year. So it's not always in that order, is it? So really what we need to do is the year is what's independent. Now, sometimes in our textbook and on other tests, on generators and other things, sometimes what they'll do to make things easier on us is instead of using 2000 and 2002, what they'll do is they'll say that t equals 0 will represent the year 2000. Or it might represent 1990 or 1980 or 1970 or some year. And so if we do it that way, then we get some easier points to deal with. So we would have 0, 25,000, and then 2, 27,500. And it technically doesn't make any difference, but it will on the second part of the problem. It'll make a big difference. So we're going to use this. So I'm going to do the change in y. I'm going to do y2 minus y1, and then do the change of x. So it looks like that's 2,500 over 2, which is 1,250. Now what would be the unit for that slope? Dollars per year. So is it increasing or decreasing? Increasing. So the librarian's salary is increasing at an average rate of $1,250 per year. Well, then the question becomes, how can we figure out his or her salary for 2006? We could do it that way. Do we really have to get the equation? No, you don't have to. But in most instances, we probably would want to. I mean, on a test question, I'd probably make you find the equation and then substitute it. But technically, once you figure out how much it's changing by, couldn't we just add 1250 a couple of times? Or we could do like Logan said, is 2006 is 4 more years, right? So 4 times that would be what, 5,000? Is that how much she's going to make then? $5,000? Add it to 27,500, right? So I mean, there's a lot of ways to proceed here. But actually, that would be the quickest way to do it. Just multiply by 4, get the 5,000, and then add that to 27,500. So this would be the answer. However, I'll be honest, there's some people who just don't think that way. And it doesn't mean that you're smarter or dumber or anything like that. It's just you think differently. And the way I did it here may not make any sense at all. So what we might want to do instead is let's just go ahead and get the equation. Now here's what's so cool about doing it the way I set it up. Do you remember how I said 0 was 25,000? What does that automatically make that point? Yes. But what's the name of that point? The y-intercept. It's the y-intercept. Isn't that your b? Isn't that the b? So see, I don't have to do all that y equals mx plus b calculating stuff. I know the equation right now. The equation would be y equals mx plus b. However, we are beyond Algebra 1 and Algebra 2 now. When the higher the math classes you get into, the more that you see that we just don't use x's and y's every single time. We start using variables that actually represents that better represents the value of it. For instance, x is really representing what? The year, right? Or in other words, time. So in most instances, we would use t for that, so it's obvious that the x is the time. And then what does the y value represent? The money or the librarian's salary. So, well, you might put S, you might put, well, you probably wouldn't want to do $sign, but S would probably be better. But you try to pick variables that better represents, the value of the variable. So don't just always use x's and y's. Honestly, most of the time they tell you. Most of the time they'll tell you. The way they'll tell you is they'll say something like write S as a function of t. And that kind of tells you what to use. All right, the B part, we've already talked about this last week, but what did y'all tell me about parallel lines? Same slope, perpendicular, opposite reciprocal. So you had a couple of questions on the homework where they gave you 2 points and you just had to tell me parallel, perpendicular, or neither. So just do the slope, no big deal. But keep in mind, you can show a lot of work or you can show very little work. Just don't put the answer though. Now if you show a lot of work, you would say xy, xy, you'd say first and second. And when I have people show a lot of work, like in Algebra 1, I make them write the formula, I make them write down all the numbers to be sure they don't make any mistakes. And then we get, 6 over 3 is 2. So that's if you showed a lot of work. If you wanted to show just the bare minimum, many of you could just look at this right here and just write down -5 minus 3, 5 minus 1, and you get -4/3. So are those the same? No. Are they opposite reciprocals? No. So you would just say they're neither. Well, what does that mean if you get neither? Well, they're not parallel, they're not perpendicular, so they intersect. Do you remember from geometry the word for when they intersect but not at a right angle? Starts with the O. Okay, Destiny, Holland, y'all remember we did this last year? Starts with the O. Oblique, yeah, oblique. Yep. Okay. So they'd be oblique. All right. So technically these would be oblique. All right. Everybody okay on that? Okay. So so this is what we didn't finish up last Thursday because of us being, yeah. Oh yeah. In most math classes it is. Oh dear, I'm not Jesus. I'm sorry. It's still neither though. Yeah. All right, I made a mistake. Darn. Okay, but yeah, but it's still neither. I can do calculus, but not arithmetic. Okay. All right. Okay, so let me save that. Okay, flip over a page then. And I need y'all to get to right here. This was the last thing we did. There was a calculator problem that the bell rang on me. So, did we finish that one? Oh, yeah. Well, let's just take a look at it real quick and at least talk through it. So, page 13, 68. Oh yeah, we did most of this. All right, if you recall, this was the problem where to use the slopes. Remember that we could literally find the slope of each line segment and see which one was the steepest and which one was the least steep. But I think by eyeballing it, he said that that was the steepest, and this one between 4 and 5 was the one that was the least steep. So that would have been A. Then we found the equation between this, and we talked about if that's the equation, does that really fit the data well? Not really. But see, you can get a linear model for any set of data. It just doesn't necessarily mean that the data, the line is a good model. Okay, when you ever hear that word, finding a model for the data, it's just a fancy way of saying find that equation that we can use for prediction purposes. Okay, the meaning of the slope. Okay, I think that's probably what we finished with, because the meaning of the slope, remember this is X here. And earnings per share, that's the Y. So it's going to be dollars per year, right? Okay, so dollars per year was the slope. And then we wrote a little sentence about it. Okay. So I think that's about where the bell rang. Did we ever write the sentence? Okay, so we said something like between the earnings per share increased at a rate on average of whatever dollars per year. Oh, sure. You can really make it fancy, but the okay. Well, the bare minimum is that you want to include the beginning and end year, and you have to include the rate. So that's the bare minimum. Okay. Just make sure it's a sentence. All right. Now, right here is another way. I remember rule 3. Oh, then we have a D part here. Let's go back to that. All right, on the D part, use the equation to estimate for 2006. So you had an equation, right? What number would you substitute into that equation? If 0 was, well, 2 was 1992. So what would you substitute in there for 2006? distinct, right? Do you think it's going to be a good estimate? Probably not, because your line's going to go this way.
It doesn't change.
Right. So, oh, I forgot, that's just a picture. Because, see, look at the difference. See, the curve appears like it's going to go and increase more upward than this is. I mean, the line's going that way. It looks like our curve is going farther up. It's growing almost exponentially. So I don't think it'd be a good estimate. So you're just kind of right. It doesn't look like it'd be a good estimate because the data doesn't really appear to be clear. So something like that. All right. So going back to the word problems, we can finish this up. All right. Now, someone was saying about making up the variables. This is really what's going to happen more and more in the homework and on the test, where I sort of will tell you the variables to use. Because look right here. It says write a linear equation that gives the dollar value V of the product in terms of the year T. And then it says let T equal 4 represent 2004. All right, so right here, it says the 2004 value is 2250. Okay. So does everybody understand that that's one of your points? What does that rate represent? Is it positive or negative? Positive. All right. Now, I want to show you on this problem an alternate way of solving and getting the equation. This is the way the textbook does it, and you may find that this is easier in some respects and harder in other respects. But the nice thing about doing it this way is that you do the problem one time and you're basically done. So let me just kind of show you this form, and then you have the choice. You can do y equals mx plus b, or you can do it this way. And this is called the point slope formula. This is y minus y1 is m times x minus x1. Now, at the beginning it looks harder, but once you substitute all the numbers in, you do the arithmetic, the algebra, and you get the answer, and you don't have to like plug back in or any of that stuff. Well, I mean, you know, y and x, that's the variables that's going to be in your final answer, so you don't plug anything in there. You plug your point into x1 and y1. Okay? So what would I write? Y minus 2250 equals 175 times x minus 4. Okay, so let's stop there for a second. In my calculus, in AP Calculus, anytime it ever says write in a linear equation, this is it. This is acceptable. They could leave it like that and be done with it, because that is a linear model. So you have to kind of read the problem to see, well, is that going to be good enough? And so sometimes they'll say general form, and sometimes they'll say slope intercept, unless it tells you otherwise. But see, here's how they tell you you're not. This is how they tell you you're not done, because it says V has to be in terms of the year, so that means V has to be by itself. So I need to change that right now. So my Y is really V, and this is T. But see, is V by itself? No. How can I get V by itself? Right. Add 2250. And then technically you're done because you got V by itself. However, if you wanted to look nicer, you would distribute, add your like terms. Well, it's not that hard. So I think that would be, what, 700? That's right. So even at first look, I mean, that form may look harder, but the nice part about it is that, you just have to write the equation once and you're done. So, yeah, I mean, you end up with slope-intercept form, but you know how in slope-intercept form you have to, plug all the numbers in and get B, and then you have to rewrite the answer. In some ways it is, yeah. In some ways. Here again, I'm not going to tell you how to do the problems. You can do it either way. I don't care. Just another way of doing it. Actually, you should have learned it in Algebra 1 and Algebra 2. But a lot of times teachers, and I used to do it this way too. I mean, I have one way that I like, and I just taught one way instead of trying to confuse you. But you need to be aware of this because in the ACT, sometimes they'll write answers in this way. So at least try one or two this way just to see if you like it or not. And then you can make a decision. So take this method then, this problem. So does it make sense this is going to be 4, 1975? And what's the slope? All right. So either with or without a calculator, do it the point slope way and see if you can do it. Okay? So plug it into the equation and then see if you get the answer. Yes. Why is it negative? Decrease. All right. All right. All right. It says a contractor purchases a bulldozer for $72,500. It says the bulldozer requires an average expenditure of $11.50 per hour for fuel and maintenance, and the operator is paid $22.25 per hour. Okay. Okay, write a linear equation giving the total cost of operating the bulldozer for T hours. So what do you think? So it's $33.75 per hour. Okay, so 33.75 T. So that's how much per hour it's going to cost to run it, plus 72,500. Exactly. Okay, that's it. Does that make sense? All right. So that's cost. All right. Revenue. Let's assume customers are charged $75 per hour. What would be our revenue function? So what do you think the revenue function will be? It'd be 75T, right? Because if I use the bulldozer for 1 hour as a customer, how much will I be charged? $75. If I use the bulldozer for 2 hours, 150, and so on. Okay. All right. So now a little economics. Profit. Profit is revenue minus the cost, right? So 75T, and then here's where people always mess up. The cost function needs to be in parentheses. Because if you don't put that in parentheses, you'll have the wrong sign on that 72,500. And it'll be all messed up, yes. So it looks like that's going to be, what, 4125T, is that right? Minus 72,500. So what do you think the break-even point means? So when would they both be even? When you make as much as you spend, so that means my profit would be When what's the same? Okay, so let's think about this for a second. Okay, so we're going to have Logan open up a lemonade stand. All right, he's going to charge 50 cents per cup. All right, so he goes to Walmart and he buys $10 worth of cups and lemonade and ice. Okay, so he spent $10. So, so what's the $10? Is that my profit, revenue, or cost? Cost. Okay, he's charging 50 cents a cup. What's that? Revenue. Okay, so when will so when he makes $10, which is the no. The $10 is the revenue, right? So the revenue is $10. The cost is $10. So what's the profit? 0. So guess what that's called? The break-even point. That's when the profit is 0. Because anything you make above that is profit, right? Okay, everybody wants to at least break even. So, you don't want to lose money. So to find the break-even points, you set profit equal to 0. So that's easy. We just say 0 equals this. Now, obviously, we're going to want to use the calculator to help us in the arithmetic, but we're still going to do a little bit of algebra here because it'd be quicker just to do the algebra and then let the calculator do the arithmetic. So we'll move this over by adding. Then we'll divide by $41.25. And then this will tell us how many hours do I need to rent or use the bulldozer before I break even. Okay. So it's whatever that is. Okay, so how many decimal places do you think we should do? Okay, well, that is actually, this is time, though, so it's not really money. If it was money, it would make sense to do 2 decimal places, though. There is no really good rule of thumb, but what I have done for years is on college board tests, SAT, PSAT, SAT, PSAT, and the AP Calculus test, they always do 3 decimal places, so that's what I want. So tell me what you got for the answer. So it'd be 0.578 then, right, hours. Because we want to do 3 decimal places, unless I tell you otherwise. Okay. All right, let's look at one more. All right, we're at Cocoa College. All right. All right, so we're at Cocoa College, and in 1980, it had an enrollment of 125. And then in 2005, its enrollment went up to 950. What does that mean right there when it says average annual change in enrollment? That's asking for the slope, isn't it? Average rate of change is always the slope. So that's change in y over change of x. So 950 minus 125. The enrollment changed by 825. And then the time changed by 25. So that's 30 something. Can somebody do that real quick? 33 even. Okay.
You can't do it unless you've been
All right. Now, we want to use this fact to estimate the enrollment in other years. Now, since I've got to do this 4 times, don't you think an equation would be nice and just plug it in the equation? However, let's make things easier on ourselves. If I made this t equals 0 and made this 25, guess what this point automatically becomes? The y-intercept. So if the y-intercept is 0, 125, and my slope is 33, see, I automatically know what my equation is. It's y equals 33t plus 125, which I'm going to call y E for enrollment, so I know what that means. Remembering, though, that t equals 0 is 1980. Enrollment. All right, so do you see where we'd go from here? I'm not going to work all 4 of these, but what would I plug in for 1976? -4. What would you plug in for 1984? 97, 17, and so on, right? Okay. Which we've already written the equation, so we answered this. But what does that slope mean? Here's our problem again. Interpret the slope in context of the problem. So between somebody? Between 1980 and 2005, the enrollment at Cocoa College increased at an average rate of what, 33, what's the unit? Students per year. Now, the way you know that is by your change in y over change of x. The y was students, the x was year. Okay, that's how you know that. And see, what you don't realize is when you're doing change of y or change of x, I mean, you're doing some calculus here because this is a derivative. So you'll learn a whole lot toward the end of this year and then all next year that you slow rate of change. That's calculus of derivative. So you're doing a little bit of calculus. Yes, we do trig. Let's call trig again. There are proofs of that. All right then. Now this finally gets us caught up from section 1.1.